Like in Google Maps use Dijkstra that algorithm. I don't remember the name. So it's supposed to find the shortest path to save path cost. That's why we need shortest path most of the cases.
So how many students are aware about this term, that is the shortest path algorithm? Because in the graph theory or in the mathematical subject, you have already studied this kind of the things, disaster algorithms and different kind of algorithm. Is any student aware about this kind of term? No one? Okay, so whatever you have shared, that is you are into the right direction, no problem. So it is better idea to understand our example through a simple concept. So let me draw a simple example. Okay, now suppose I'm taking the real example, and I believe in to understand each and every concept to the real kind of the application. So we will much aware about that part. So okay, so I'm taking here example. This is the okay. This is the Sihor city. Actually, I'm just taking the real example. Then other student as well as can understand in proper way. Now this is your city. This is your city belong to its kind of vertices and nodes, and it is connected to the other city. This is known as the Bhopal. Okay. Since when we're talking about the shortest path algorithm, then it is also followed by the concept that is known as the directed acyclic graph. So if you're saying this is directed, so we need to keep in mind the arrows. Now, this Bhopal is also connected to the other cities as well. I'm just taking the simple example like Agra. And Agra is connected to another city, that is Delhi. Now, Sihar is also connected to the our another city which is known as the Indore. I am taking this example because you all are about the this locations or all these cities as well. So Indore, okay. Then Indore is connected by the another city and directly, not indirectly. Directly, we can say we have the Gwalior, and in between the Gwalior and Indore, we have the other cities like Guna and Sipri. So those students who are aware about such kind of cities, they are familiar with this kind of the. Okay, so if we want to go Delhi, then of course we will go by Agra. So Gwalior to Delhi. And Bhopal is also connected directly by Gwalior itself. Okay, and Bhopal is also connected by Indore with its route and vice versa. So this is the example I can take, and yes, I can make this example bi-directional, but right now I'm taking only the simple example over here. Now, is it okay? This example is clear to okay? This example is clear to all.
Yes, sir.
But
Yes, sir.
okay, now there is a person that is name. I'm just taking the random name, so I'm taking the random name of that is Golu. Okay, Golu want to go Delhi from Sihar to Delhi. Then he is staying into the Sihar city or Sihar town. Then what is the path he will choose? Please let it be know. Please let it be know.
From Bhopal
Sir,
to Agra to
Bhopal,
Delhi.
Agra.
He can go via the CO to Indore and Gwalior and Agra and Delhi as well.
But that is long path, na, sir.
That is a long path. Okay, that is a. But how you determining this is a long path or this is shortest path?
Sir, more cities have come in that path, and only Bhopal in upper path.
Okay, whatever I'm speaking over, it is a part of the fundamental, and without the weights and cost or distance, how you determine this is the shortest path you are picking or longest path. So
Sir
again,
cannot determine, sir. You must have to
yeah,
give
yeah,
values.
yes, that's the point Anis is saying, absolutely right. We need to define some distances, we need to define some cost of the edges, and we need to define some weight. Okay, so that's the point. This is only a directed graph only. This is not a weight directed graph, or we can say directed weight graph. So it is necessary for solving the problem. You are looking for the shortest path algorithm, or you are looking for the shortest path finding approach in a graph theory or graph data structure. Then it is necessary you must have a weight metric, a weight graph. Okay, weighted graph we can say, and that could be the undirected or directed. So CO2 profile, I'm just taking the just simple or not exact, it is just tentative values. So CO2 Bhopal, we can say it is approx we have the 40 kilometers. Okay, and okay, just no, okay, yes, absolutely. And Bhopal to Agra, if I'm going through directly without stopping Gwalior itself, so Bhopal to Agra, I can measure it took around 120 plus 400, so it is would be around approx 520 something. Okay, and all the values are coming into the form of the kilometers as well. And Bhopal to Gwalior, I can measure approx like 400. And Agra to Delhi, we have approx 390. So we need to use this 270 around 270. And Indore to Gwalior, it is just measured by approx 490 something. And to the best of my memory, it could be vary, but it's tentative. And CO to Indore, it, approx we have 150. So now on this weight or in on this distance, on this cost, you can say CO2 Delhi, and Golu wants to visit. Okay, now the Golu is a person and who want to go. Okay, I'm just taking the very genuine examples, and you can feel. Okay, so now Golu want to visit Delhi from Sihor. So what the path he will choose? Definitely Sihor, Bhopal, and Agra and Delhi he will choose rather than the picking the Sihor, Indore, Bhopal, and Agra and Delhi, Sihor, Indore, Gwalior, Agra, and Delhi, and he has a multiple path as well. Okay, so this is the point we need to keep in mind. So for solving this problem, we have a shortest path algorithm. Okay, so first we need to understand the fundamental part why we are understanding the shortest path algorithm. Okay, so if any question I'm asking to the examination, or anyone asking into the examination or anywhere, then please see this important point: the distance or cost is given or not. Okay, so that's the point. If distance is cost is not given, then you have to assume for solving a problem. And to keep in mind, we have to keep in mind the words, finding the shortest path, we can pick the right path. Okay, no problem, by finding the shortest values. But traversal, we are doing like we are doing the normal traversal followed by the DFS or VFS, it could vary depend on the choosing the source. Okay, so we are selecting, suppose we are solving this question for finding the traversal approach or this DFS or BFS. I am taking the Bhopal as a my source vertices. Okay, you can take the Indore. So definitely based on the choosing the short source vertices, it could vary or the diagram may vary. But in case of the choosing the source vertices into the shortest path, again your diagram may vary. So it is better idea to choose a almost left side, or we can say the बिल्कुल touching the left side part of the or vertices. Okay, so this is better idea. So whenever we are solving any problem, like we are solving this problem, then we will choose the Sihor is the source test vertices, from where we will start the work, and Delhi would be the our destination. So this could be the path. Now Gwalior and Delhi can be connected directly, because now there is no train will stop from quality to the least, so directly we can jump. So we can also calculate over this path as well, so no problem. And there will be the multiple paths, so this is the shortest path problem we need to solve. Okay, so if this point is clear to all why we are understanding the shortest path algorithm, then shall I move ahead? Yes, students, speak up. Shall I move ahead, or if you have any doubt over here?
Yes, sir.
Okay. So shortest path algorithm means this family of the algorithm which is used to solving the shortest path problems. Okay, so this point we have already discussed. Now point come to the point over here, the applications. What is the application? There's lots of the applications we have over here, but right now we have the real application, that is the Google Map. As one student told us to that, so in the Google Map we have the biggest application or big advantage of the shortest path algorithm. Wherever we need to find the shortest path. Now, if you are visiting any city alone or with someone else, but if first time you are visiting, then on the Google Map you will visit the shortest path for finding the relevant value. And definitely something information which is stored onto the previous data based, or some based on the distances as well. Like you are visiting the Nagpur. Okay, first time you're visiting Nagpur, your first time you're visiting the Hyderabad or any city for interview purpose or for visiting purpose with your family as well. So now you want to visit the temple or any mosque, or any new places. Okay, then what happened at the time? You are unknown to that place. Then you have the good mobile. On the good mobile means you have the mobile which is having the facility of the Android based application installation. Then you have the Google Map. On Google Map, you what you are doing, you are searching the particular destination, and you will choose the source path or source point, that is your current position, current location we can say. And from the current location you will choose your destination point. So you will see there could be the multiple way, depends on the which route you are picking. So you will it will show, or Google Map will show the shortest path, and these things you have already seen into your Google Map application as well. Now road network definitely, of course, we are this is the example we have seen in the previous slide. We want to move from the CO to Delhi by the road. So which path I should pick, so that the algorithm will determining this is the shortest path. Okay, so this slide is clear to all. So where the application we need to go
Yes,
for?
sir.
Okay, so I'm going to the shortest path problems can be solved by the various approaches. So number one, we have the single pair shortest path problem. Single pair shortest path problem. Keep in mind the words. Next, we have the single source shortest path problem. Next, we have the single destination shortest path problem. And now we have the all pair shortest path problem. So shortest path problem can be solved by the four different approaches. Number one, single pair shortest path problem, single source shortest path problem. Next, we have the single destination source shortest path problem, and last one we have the all pairs. Now, question comes in our mind, so what is the difference between all these kind of the shortest path problem? So we have single pair shortest path problem. So I have written the all the algorithm name into the red color. Then you will see that is a star algorithm will use into the single pair shortest path problem. But what is mean by the single pair shortest path problem? So you can see it is shortest path problem where the shortest path between a given pair of the vertices to be computed. Okay, so how you will determine? You will determine that is we have the shortest path between the given pair of the vertices to be computed. So this is the point we need to keep in mind. And for solving this problem, we have the A star search algorithm. And this A star search algorithm can be understood by the our important course that is known as the artificial intelligence, where the machine will determine the shortest path through the its given pair of the vertices. So all the information between the shortest path between all the vertices to be computed or fed up into the machine as well. Now we have the single source shortest path problem. So what we need to do in this problem, where the shortest path from the given source vertex to all other remaining vertices to be computed. So this is the point where we have discussed into the our access our problems. That was a CO2 Delhi you want to visit, or is Golu want to visit CO2 Delhi. So which is the shortest which is a source vertex, that is a Seoul. So Seoul was the source vertex, and from which he just need to move Delhi, but rest of the details he just known to about only the connected. So CO to, now see, come to the point. CO to Bhopal, he knows the distance and he knows the Indore, but he doesn't he does not know about the distance from CO to Agra. So first he need to cover the Bhopal city, and then from Bhopal he will see the shortest path. So first he need to come to the Bhopal. If he is choosing the this city, maybe he can go into the, or he may go into the Indore city, because now Indore is 150, so he will not cover the 150. But suppose he want to go Bhopal, so CO to Bhopal he can go directly, and there is another way. What is another way? CO to Sihor to Indore and then Bhopal. So this is another way, but this part will be the longest part. So definitely this part, this concept we will see into the our important algorithm, that is a disaster algorithm. Now, Indore to Bhopal we can compute, like I'm just taking the normal way 200. This was a missed distance we have. So now I will return over here 200 approx, now tentative values. So definitely if I need to go Sihor to Bhopal by Indore, 200 kilometer, approx 200 kilometer I will cover. So I'm just wasting my time over here. Okay, so it is better idea to come CO to Bhopal via 40 kilometers. So this path is very shortest path. Now next we have single destination shortest path. In this kind of the problem, what we need to do, the shortest path problem, where the shortest path from the order vertices to a single destination vertex is to be computed. Okay, so this is the point we need to keep in mind. But by reversing the direction of each edge in the graph, this problem reduces the single source shortest path problem. So first we need to cover the distance at the we cover the distances of till the destination point, and then we need to reback, or just kind of we can say this is a approach can be understand by the our important term, that is a backtracking. Through the backtracking we can see is it correct or not. Okay, so this is also done by the disaster algorithm. So disaster algorithm and Bellman Ford, these are the two algorithms which are come into the single source destination shortest path problem, while disaster algorithm also can be used to compute the single destination shortest path. So this is a good example, and today we will try to solve this problem through the this kind of the approach as well. Okay, so this is the most famous algorithm, that is the disaster algorithm. Disaster algorithm is most famous. Why I'm taking the most famous? Because when you study the graph theory for finding the shortest path, then disaster algorithm play important role to deal with to find the shortest path. And same thing you are applying into the computer network as well, where we need to find the shortest path. So we will start our study from the disaster algorithm. So disaster algorithm is applicable into the data structure, computer network, graph theory, and anywhere. So the fundamental concept of the disaster algorithm will be applicable into the anywhere, like computer network subject or course, or data structure, as well as the graph theory. So that's why the all the people who will look for the shortest path algorithm implementation, then he or she will try to implement the first disaster algorithm, then go for the other algorithm as well. Now this algorithm also have disadvantages, and that part we will see later on. But now come to the point, the fourth one, that is all pair shortest path problem. On the all pair shortest path problem, what we have, it is shortest path problem where the shortest path between every pair of the vertices to be computed. So definitely this algorithm will take much time. So we have the Floyd Warshall algorithm and Johnson algorithm. Why I'm taking Floyd Warshall algorithm in the red color? Because disaster algorithm and the Floyd Warshall algorithm are the part of the our curriculum, so we will see only these two algorithm. Now you can see the Bellman Ford algorithm. I'm not colorized by the red color. Why? Because this is not part of the our curriculum, but this is the most famous algorithm where we study into the computer network course, and this is the most famous algorithm for the computer network. subject as well. But Johnson algorithm is little bit different from the Floyd-Warshall algorithm, but this algorithm under come into the category of the all pair shortest path problem. Okay, so for solving the all pair shortest path problem, now in the single pair we need to look for the between the given pair of the vertices. That pair will be given to you. In the single source shortest path, we need to start from the source vertex, and we need to compute the other remaining vertices as well. In the single destination, the single destination vertex is to be computed. So that's the point we need to see. And all the pair vertices between every pair of the vertices. Okay, we need to compute all the things between the every pair of the vertices, and that is undercome into the Floyd-Warshall algorithm and Johnson algorithm we will see. So that's why we have the four category of four types of the shortest path algorithm. Okay, so this is the point you need to keep in mind while learning the shortest path algorithm. Now, is it okay? All these kind of the shortest path problem. ये सब क्लियर हो गया कि शॉर्टेस्ट पाथ प्रॉब्लम हमारी चार तरीके से होती हैं, सिंगल पेयर, सोर्स, सिंगल डेस्टिनेशन, ऑल पेयर। सिंगल पेयर में हमको क्या करना होता
Yes,
है?
sir.
हाँ, सिंगल पेयर में क्या करना होता है कि हमको हर एक पेयर के बारे में डेस्टिनेशन जो वर्टाइसेस है उनके पेयर के बीच में डिस्टेंसेस कैलकुलेट करनी पड़ेगी। ओके, सिंगल सोर्स में सिंगल सोर्स दिया जाएगा, वहां से हम कंप्यूट करना स्टार्ट करेंगे, पर अदर वर्टाइसेस कंप्यूट करेंगे। डेस्टिनेशन और सिंगल डेस्टिनेशन में क्या होगा? सिंगल डेस्टिनेशन हमको दिया जाएगा, वहां से हमको करना पड़ेगा, वर्टाइसेस की डिस्टेंस कैलकुलेट करेंगे, और हम उसको रिवर्स भी जाके देखेंगे कहीं ऐसा तो नहीं कि दूसरा कवर करने पे दूसरा और शॉर्टेस्ट पाथ निकल आया। ओके, एंड दैट इज पार्ट अंडर कम इनटू द डिजास्टर एल्गोरिथम. सो वी विल सी all these concepts through the numerical way as well. And all the pair vertices, what happen? Every pair of the vertices, if it is shortest or unsorted doesn't mean, but we need to compute as well. So it takes much time. Okay, so if we're looking for the time complexity, definitely the Floyd-Warshall algorithm will take much time compared to the disaster algorithm. So shall I start with the first algorithm, that is the disaster algorithm? Okay. So shall I move to the another slide?
Yes, sir.
Okay. So in the disaster algorithm, theoretically I have written here for the examination purpose and notes purpose, you can see. So disaster algorithm is published in 1959, is named after discoverer Ezra Dijkstra, and who was the Dutch computing scientist. And this algorithm is to find the shortest path in the directed or undirected graph with non-negative A's. We need to keep in mind with non-negative A's weight. Okay, so weight will be given to the only the positive wave. This is the point we need to keep in mind. So this is a drawback actually. Again, because we have already the positive weights, we can't have the negative weights as well. And before understanding all these things, we need to keep in mind we must have a graph. Okay, graph must be non-linear. So this is a general term we have, weighted graph. So every age will be assigned by the numerical value, that is also known as the weight. And connected graph, why connected? Because each and every pair is connected to each other. So path, there will be exist some value or some information that is known as the path. So that's why it is known as a connected graph. Span tree, why it is span tree? And a graph can have the many span tree. Am I right? Can a graph have the many span tree?
Yes, sir.
This is a question I can ask into the examination for the confusion purpose. Suppose I'm asking this question, justify the statement a graph can have the many span tree. So how did you resolve this problem? Now tell me. This is a question actually. This is a good question.
Sir, it depends na from which node we are taking the DFS and BFS. Then depending on that, the spanning tree will be different.
Yeah, of course, of course. So what happened? I'm just see this graph A, B, C, D. Okay. Suppose I'm choosing A, so I can go C and B as well. I don't want to go, or I don't want to visit the B. I want to visit C only. So I can make this graph like A to C, D and B. Okay, there's no cycle. A to B, like just I'm taking this example, like, okay, just for the revised purpose. A to C and C to D and D to B. I can go, there is no cycle. This is my span tree. Okay, and another span tree could be, I'm just taking another color. I'm going to, or I'm visiting node A to B, B to D, and D to C. Again, there's no cycle, so it is a span tree. So how many span tree now? We have the two. Another could be, I'm just taking the different color. A to C, C to B, and B to D. So again, we have the third one. Okay, so a graph can have a many spine tree. Okay, so this is a point we need to keep in mind for the examination purpose. And with this kind of the example, you can draw the 3 or 4 different kind of the spine tree, and you can explain a spine tree is a subgraph of a given graph. Okay, so a spine tree is also known as a subgraph. Now, is it clear to all? Because span tree is the most important part for solving the problem into the next, not exact next to next class. Whenever we see the finding the shortest path from the other thing, so we have the other approach. Okay, the critical and finding the minimum span tree. Okay, what happened in a graph? We have the various span tree. So which span tree is minimum weight, minimum having the weights, and we will see this part through the coming classes. So a graph can have a minimum span tree. So shall I move ahead with from this point?
Yes, sir.
Okay, because this is an important part. Once you have missed all the points, then you will be suffer. So I'm just taking the one by one step properly for explaining the disaster algorithm because it is the most important algorithm. Now problem statement. What the problem statement we have? Given a weighted graph G, the objective is to find the shortest path from the given source vertex to all the vertices of the G. Source vertex to all other vertices of the G. Okay, this is our main important objective. Okay, so we need to follow this approach. And the graph has the following characteristic: set of the vertices. Of course, we have the set of the vertices undoubtedly. And suppose I'm having the set of the vertices V. So number of vertices can be B1, comma B2, and so on, so on, so Bn. Suppose I have n number of the vertices. A set of the weight ages, that is E. So E is the ages, and that is also represented by the set of the ages. So I can take E1, comma E2, comma E3, and so on, so En. So I have the n number of the vertices or m number of the vertices. Okay, suppose I am the n number of the vertices 5, so A is made different. Okay, so ages would not be positive or equal to the number of the vertices. That's what I'm seeing over here. May or may not be, so I'm just taking the different value m. So it is represented by the some value that is known as the q. So if we have the vertices b1 and b2, okay, please understand all the words properly because through these points we will see the our examples. So such as is e and qr. So q denotes the and denotes the age between the vertices q and r and the cost, that is qr. So suppose we have the vertices b and b2, and that is also represented by the q and r. Okay, so we can write this one like is e b1 comma b2, or we can write is q comma r as it is written over on the our slide. And we can also determine this point. This is the cost between q and r. And suppose I have the cost 10. So the cost of these two vertices or this age will be 10. So cost of the qr will be the 10, or cost of the b1 and b2 will be the 10 without any problem. Okay, so this is an example. Now is it clear to all what I'm doing over here? Because we have the set of the vertices and we have the set of the edges. Shall I move ahead? If we this slide is clear to all? Yes, student, please do fast.
Yes, sir.
Okay, now in the disaster algorithm we need to understand all the points properly. This is single source shortest path algorithm and the aim to find the solution to the given problem statement, and what the problem statement it is already given. The algorithm works for both directed and undirected graphs. Okay, so this is the point we need to keep in mind. This algorithm works for the directed or undirected graph. But in this example, what we have, this is the directed. Okay, so it could be undirected as well. CO2 Bhopal, you can go CO2 Bhopal or you can go to the Bhopal to Sierra as well. So this will work for the both. This algorithm will work for the directed or undirected graph as well. It works only for the connected graph. Why it is connected graph? Because all the nodes must be connected. Okay, the graph should not contain the negative age bits. This is the point we need to keep in mind. So this determining that we must have the weight value in form of the positive. Okay, so we must have the positive weights. Like 10, 20, 50, but I can't have the -5, -6, -7, and so on. So and the algorithm predominated follow the greedy approaches. Now greedy approaches, why it is known as the predominant greedy approach? Because in the analysis of the algorithm we have already discussed, we have not discussed, but it is a part of the uh, various technique where we need to follow the some approaches, and those are the greedy and other approaches. So in which what we need to do in the greedy approach, for we need to find the locally optimal solution, and greedy approach is just having own meaning. So same thing, or from the part of the greedy approach we can over here. So this algorithm predominantly follow the greedy approaches. Now greedy approach has the or different meaning, but somehow it looks like the same thing. And in the greedy approach we can also follow the finding the distances when we need to calculate the something from the two vertices, and that is to be managed by the A's and weights. So that's the point we need to follow the greedy approach as well. So from this point, or we can say the from the inspired by the greedy approach, we need to measure distances or minimum distances. And same thing we can over here. The greedy approach is basically uh, implemented, little bit implemented in form of the disaster algorithm, but it also use the dynamic programming approach for the building the globally optimal solution. So since the previous solutions are stored and further added to the gate final distance from the source vertices. So same thing, we have the another technique that is known as the dynamic programming. Those students who are taking the course analysis of designing algorithm, I think they will be familiar this kind of the burst, that is a greedy approach and dynamic programming. So in the dynamic programming, what we need to do, we need to store the previous solution or previous values on the previous values, or from the previous values we will determining is it required to keep this value for the measuring the another path or another value. So that's point we have written over here, and it is better idea to understand the with an example. So we will clear all this word, but some theoretical part is required for solving the numerical as well. So main logic of this algorithm based on the following formula, that is a distance r. So distance r can be calculated by the minimum there's a function which will be determining the minimum value from the distance r and distance q plus cost qr. Okay, and so we have the two r. These are the vertices q and r. So from q to r, what we need to do, we need to find the minimum distance of the r. Okay, and then distance of the q plus cos q plus r, and that will need to be added over here. So we will find the this path. And why? Because q may be connected to the another value like s. Q can also be connected to the t. So we will compute distance r, distance t, distance s from the q vertices. Okay, so this is the point we need to go for, and that's why it is known as the disaster algorithm, because disaster algorithm will maintain all the information in the form of the distances. So each and everything will be maintained by the distance as well. So this is the point I'm taking over here. Okay, shall I move ahead? If there is no doubt over here, then shall I move ahead? Because this formula you have to keep in mind. Yes, student, please tell me. Shall I move ahead? Today we will see this algorithm proper way because this is important algorithm. That's what I'm saying. Yes, student, please tell me. Shall I move ahead?
Yes, sir.
Okay. If you have any question over here, then you can ask me, because if you're looking for the greedy approach and dynamic programming move, so that is a part of the analysis algorithm, or is a different part. When we look for the finding the shortest path or finding the optimal values, then greedy approach to dynamic programming play important role to deal with the finding the optimum value. But here we are finding the shortest path. Okay, so from the optimal value optimization, or from the getting the optimal value optimization path, so greedy approach and dynamic programming deals with, so in which what we need to do, we need to do the measuring the minimum distances, okay, from the its previous value, and previous value will be hold. So from the previous value and next value we will choose the which value is better. Like the simple example I can take here, very simple example. Now you have suppose you have right now the a good mobile, and that is cost by the 10,000 rupees. No problem, all the feature are given into the your mobile. Now you are looking the another mobile for the same feature, and if it is cost around the 12,000, so you will not go through the 12,000 cost, 12,000 budget mobile. Why? Because right now you have the same specification your current mobile, so you will keep this one. But it is found that there is some offer is available into the on the 12,000 mobile, and now 12,000 mobile is we can buy approximately 8,000. Now we are getting the 4,000 discount. So definitely you will pick the 8,000, because 8,000 is minimum than the 10,000, and while 10,000 is minimum than 12,000, so you will pick the minimum value. Same thing from taking the example here for distance purpose, so you will choose the minimum distance rather than the longest distance. So same thing we are happening over here. So this is the formula we need to keep in mind. Distance r can be calculated by the minimum of the distance r, and and distance q plus cos q and r. Please keep in mind we have the bracket. So this bracket determining that is this is the one dimension array. Okay, so this is the point to keep you have to keep in mind. And now cost. The cost between q and r will be two dimension. Why two dimension? Suppose you have the distance qr 5. Okay, now you have the cost from q to r. What's the cost we have? 5. Can we say? Can we say? Cost between q and r. Can we say we have the 5? It is written over the slide. Please see the slide.
Yes, sir.
Okay. The cost between q and r can be done by the s, q to s and s to r. So it will be the 2 plus 1. Now we are getting the distance from q to r by s, that is 3. So which value we will pick? Q to r by q to s and s to r. So this is the
Yes, sir.
point. That's why it is determined by the two dimension array. So this is the point we need to keep in mind while implementing purpose. So that's why I'm just explaining all the words properly. Once you have missed one value, definitely you will get confused, and within the few minutes you can't solve this question. So to avoid the problem, to avoid the issues, and to avoid the uh, any kind of mistakes, it is better I need to listen properly each and every words. Now if this point is clear to all, then I can move to next slide. Okay, so I can move. So shall I move?
Can you explain with one another example, sir?
Yes, sir. So I'm just taking another example. So let me uh, add one more slide over here. We have a beaver over here. Now there is a some nodes, that is a. There's some nodes and vertices are connected with each other. So I'm taking right now the undirected, there is no problem, because this disaster algorithm works for the both kind of the graph, directed or directed. Okay, now tell me the A's values. So A to B, what value I must take?
50.
Please, how much?
50.
15 or 50?
50. 50.
Okay, thank you. And B to C?
13. 13.
Okay, good. Now A to D?
45.
Okay, good. And please continue with me. And B to D?
38.
38. And B to E?
20.
20. And last value I need ask from your side, C to E?
60.
60. Okay.
So D to E also you need the value, no, sir?
D2E, sorry, I just forget this one. Okay, D2E, what value?
48.
Okay. Suppose I need to need the cost from A to B. Okay, and then between I'm checking for understanding purpose. B to E. Okay, I need to calculate the distance from E to B to E. Okay, so I'm just picking the cost from B to E. Okay, so I'm writing for understanding purpose C. C is the cost. Okay, for understanding purpose. So how many path we have? That's the point we need to keep in mind. B to E. You can go via B, comma C, comma E. And what is the cost? I can write for understanding purpose in simplification way. B, C, E. 13 plus 16. Can I write 73?
Yes, sir.
Yes, sir.
Okay. And next value we have B, D, E. So we need to pick B, D, and E. So I can take 38 plus 48. So definitely it would be around the 16 plus 17, 86. Okay. And
Yes.
another director I have, that is B, comma E, that is a 20. Okay. So these are the three costs for calculating distance from B to E I can have. Okay. Am I right?
Yes, sir.
Yes, sir.
Okay. Yeah. Okay. So little bit I am updating over here. Suppose here you need to pick the which value, that is B to E, that is a 20, which is the shortest value we'll pick. Okay. Now let me do some amendment. If suppose if this value is approx 90, so will you pick this value for calculating the path? Will you pick?
No, sir.
No. So
No,
which
sir.
No,
value
sir.
you will pick? No. So which path you will pick? That is 73.
BC.
So you will pick B to C and C to E. That is the shortest path. Okay. And that is also maintained by that is also managed by our Dijkstra algorithm. So that's why this cost will be determined by the two-dimension array. That's why I'm saying over here. Okay, this is the point. And if I'm talking about the distance of the q and distance q of the r, that is also maintained by the single value only. So that's why it is represented by the one dimension. So the cost of any is or between the two different vertices will be determined by the two-dimension array. So it is not 20, it is two-dimension. Okay, it is 2D. Okay, so this is the point you need to keep in mind. Okay, I'm just let me write the correct, because I will save this PPT for the notes purpose. So I can write okay, I can write okay, it's two dimension. Okay, so that's why I'm saying. So that's why it is written over here. C a cos is written into the two dimension. Now it is clear because it will keep the multiple values. Okay, now shall I move ahead for from this slide?
Yes, sir.
Okay, okay, so okay. Now, so the formula is stated that the distance vertex, that is R. Oh, where is my pointer? Yeah. And the adjacent to the vertex Q will be updated if and only if the value distance Q plus cos QR is less than this value. If this value, which is to be calculated and followed by the distance R, if this distance is value less than its newly added cos, so definitely will pick this value. So depend on the circumstances. And this part I've already explained. Distance is a distance is a 1D array. Okay, so why? Because at every step or each step it will keep the track of the shortest distance from the source vertex to all other vertices. And cos is a two-dimension array, as I spoken already. And as I spoke you, representing the cos adjacency matrix for the graph. Okay, so that's why I'm saying over here, this is already point I will discuss here. And now this formula uses the greedy and dynamic approaches. Okay, so the greedy and dynamic approach, you will feel or you will understand from where you will study the analysis of the algorithm for the finding the optimal. So grading and dynamic approaches are used for the finding the optimal path. Okay, so that's why from this inspired from this kind of approaches we will use this formula, and the formula is distance r is equal to minimum distance r comma distance q plus cos cube r. So that's why we have the this idea. So we will choose the we will pick the minimum distance. I'm just reading the point over here. The greedy approach is used to for finding the minimum distance value, whereas dynamic approach is used for the combining the previous solution. So this dq is already calculated and is calculated with distance r. So that's why in the Dijkstra algorithm we have both approach or both concept, that is a greedy and dynamic approaches for finding the optimal path, and how to determine, that is finding the minimum based distance. So this is the point we need to keep in mind. So I'm just coming to the next slide for betterment to understand the its simple algorithm. So algorithm is not a tough. The algorithm we have already discussed over here. This is the algorithmic steps, and this is general algorithm where we need to go through the our solution. And in the algorithm, if we need to solve this problem, so what the input are required? Input requires the cost adjacency matrix for the graph G, say cost, and source vertex, that is the S. So output data, that is spanning tree, have shortest path from S to all other vertices in G. This is the point we need to keep in mind. Suppose I am choosing the source Bhopal rather than the Sihor. Okay, then what happened at the time? The shortest path may difference. So this is the point we need to keep in mind, which path you which source vertex you are picking. So this is the point you need to keep in mind for choosing the source vertex. So it is better idea to choose a source vertex from the left side only, and at most left side values. So this is the algorithmic step we have for solving the questions. So this is the basically we can say all the step-by-step term which is written into the for giving the solution for the numerical problems we have. Why I'm just going to into the step-by-step, because in this step-by-step solution just provide the solution in easy way. So in step number 1, set distance as equal to 0, because initial distance will be the 0 and this s will be the psi. Okay, this is a numerical value or some mathematician we will use. So s is the source distance we are picking, and s is the one dimension array as I spoke you. And second step is saying that all the nodes v except s, so that will be the distance v will be the infinity. So this is the point we need to keep in mind, because I don't know the other distance where I can move. So first I need to calculate the distance. Suppose you are coming from Bhopal to you are coming from VIT Bhopal campus to Bhopal. Okay, so VIT Bhopal campus to Bhopal. So first you need to come on the closest path, that is a Kotri, and then either you can go to the Asta, you can go to the Bhopal or Sihor. But going to the Bhopal or going to the Indore or going to the other places, you need to measure the which is the shortest path, and you don't know the other distance as well. That distance to be what we need to do. That distance we need to infinity for us. We don't know. So we will cover the next distance, and then we will cover the next distance. So distance will be measured or calculated by the covering path or covering nodes as well, we can say. So because we are not known to the particular distance only. This is example, you can say, like if I'm coming from Bangalore to Delhi. Okay, so Bangalore to Delhi, I know this is the total distances we have, but we have the lots of the path. Which path I need to choose? Okay, so first Bangalore, I will choose the closest values. So Bangalore to Hyderabad, I'm choosing. So I will be familiar with the Bangalore to Hyderabad, and then Hyderabad to other place I will choose. So Hyderabad, Bangalore to Delhi, this value familiar, but I have the many paths, so it could be vary. So Bangalore to Hyderabad, I will known to because it is connected to me directly. But though those vertices which is not connected to me directly, and the distance will be for those node and vertices in form of the infinity, because it is unknown to me. So this is the point it is written over here, that is the infinity distance we have. Now it is clear to all, because this is the point we need to keep in mind. Step number 2. Any doubt? Let it be know.
No, sir.
No? कोई डाउट है तो प्लीज क्लियर कर लीजिए, क्योंकि स्टेप समझने के बाद हम सॉल्यूशन करेंगे तो कोई डाउट नहीं आने चाहिए, इसलिए मैं बोल रहा हूँ. प्लीज लेट इट बी नो.
No doubt, sir.
Okay, so I'm coming to the my next step, that is the find q. Q is the vertex. So find q not in S such that distance q is will be minimum. So because vertex q should not be visited, add q to the S and add vertex q to the S since it has now been visited. So we will add q because it is connected and we have visited this node, and update again distance r for the all r adjacent to the q. This is like example of this one. Now this q is connected to the T, S and R. So R will be connected to the T, R may be connected to the S. So from this node we again calculate the other part as well. And we will apply the gradient dynamic approach over here to find the minimum distance, and we have the point over here. And repeat step number 3, 4 and 5 in a loop to cover the all the nodes that have been visited or not visited. If it is visited, then we will update some value if we finding the minimum value, and print the distance. So this is the programming way we have over here. So 7 step or 8 step I'm not going through, because it is just printing the all vertices distances value where whatever we have covered. Now this is the example. So it's a better idea to understand the example rather than the much focusing on the algorithm, because once you have understood the example, then you will understand all this step properly. Okay, so all the steps whatever we have did over here or we are doing over here, we will cover into the example. It is better idea to understand the example. Now here for understanding the disaster algorithm, I am saying to all, please use paper and pencil, because this algorithm is most important algorithm. Okay, use paper and pencil. Please use paper and pencil for solving this question, and make this graph on your paper. And now see, this is what, this is a undirected graph. Can I see? Please student, are you doing with me? Please use paper and pencil.
Yes, sir, trying to.
Yeah, no, you all have to do, because once you have done the mistakes, and definitely you will get confusion. So I don't want any kind of the confusion for solving these questions. Okay, so which is the our source vertex? As I spoke you so many times, it's a better idea to choose a left or utmost left value, or utmost left vertex, that is the S. So S, can we say this is our source vertex? I will ask one by one to all the student, please, because this is a necessary example where we will understand the point. Oh, let me do one thing. Okay, one student just send me message over here. Okay, it was the previous one data. No problem. Did you all note down the example? Justin, please communicate me properly so I can understand you are doing with me.
Yes, sir.
Yes, sir. Yes, sir.
Okay.
Sir,
So
1 second, sir. 1 second.
okay, please, because it is necessary part, because it is a most important part for understanding the shortest part in the graph data structure, and it is the most important algorithm because this algorithm is applicable anywhere. And now the few student in between just drawing this example, in between I can say a few words over here that S is directly connected to A and C only. Can I say S is directly connected to A and S only, A and C only?
Yes, sir.
So
Yes, sir.
S is not known to the distance from S to B, and so the distance from S to infinity, can I say? Because S doesn't know this part, it is connected to B, because there could be many paths like S to A, B. If I need to go, then I can use a very paths like S A C B, S A B, S C D B. Can I, or S C B? I can take the various path, or maybe S A C B. Okay, so this could be the any path. So that's why the S
Yes,
to
sir.
B, those S to B, it is, we can say it is infinity. Infinity determined it is the S doesn't know the path of the, or the distance of the path, or we can say distance. So S doesn't know the distance value of the B. Okay, from S to B. Okay, it could be anything. Okay, because we are familiar with the many path. But S is directly connected to the A and C. So S known the, or S will keep the information about the S to A and S to C directly without any problem. Okay, now if the student is drawn, so I'm just jumping to the my next slide. Now this is the point. So what is step number A? Step number A says that initialize the distance array distance dist using the following step, that is algorithm. We have set distance S is equal to 0 and S is equal to psi. Okay, 5. Here we have the size. Now this not size is a 5 actually. Please keep in mind it is a depend on the font size. So it is a 5. 5 determined that is S will S is just not connected to the, it is connected to the A and B, but S is not having the own value. Okay, so it is representing the self representing. So U is the source vertex and S is the one dimension having the visited nodes. Okay, this is not U, it is a S actually. It is a typing mistake. So please keep in mind. S is a source vertex and S is a one dimension having the all the visited vertices. So for all the nodes B as distance B will be the infinity. Okay, so you can see an updated diagram over here. S will keep the information about A and C. So S is directly connected to over here. Okay. Any doubt over here? Initially, all the information will be maintained by the our this array, that is for that is infinity, because S is just initial value, so there is no distance 0. Okay, and A is infinity, B will be infinity, and C will be infinity because S to A, S to B, S to CD. So it is known unknown to, because we are doing starting. Then first we will see which path we should pick. Then shall I move ahead?
Yes, sir.
Any
Yes,
doubt?
sir.
स्टार्टिंग में एस के पास सेल्फ लूप है तो डिस्टेंस उसकी 0 हो जाएगी. अब वो आगे बढ़े उसके पहले वो स्टेप लेगा, लेकिन उसके पहले सारी डिस्टेंस कैसी है उसके लिए अननोन है. अभी उसने चलना स्टार्ट नहीं किया है. ओके, दिस इज द पॉइंट. तो एट इनिशियल वे, दिस इज माय पॉइंट. ओके, उसने चलना स्टार्ट नहीं किया है एट द इनिशियल वे. So all the distance will be maintained by the some vertex or some set of the vertices. We can say it is maintained by the only the infinity, we can say. Okay, if this part is clear to all, then shall I move ahead?
Yes, sir.
Okay. Yes, sir. Okay. So now choose the source vertex S as a distance as a minimum, and S is not in S. The smallest means this is represented by the vertex source, and S represent the what is S represent the capital S means, so we can say one dimension array. And find Q not in the S. So this is a theoretical part. I'm just coming to it is better idea to explain through the example. Now read only the important part over here. Just this is only the theoretical part, so it's a better idea to explain the reddish color point. Now if we need to calculate the distance A, if I need to calculate the distance A, then there is a formula very easy: minimum distance A. This here we can say this A means we can say the Q into our example or solution, we can say. And okay, this part can I say, and so formula will be the minimum distance A comma distance S plus cost S comma A. So minimum value will be the distance of A. What is the distance of A? Initially it is given that is infinity. Okay, comma distance of S, that is what the distance we have, that is a 0. And cos from S to A, what the S to A we have, that is 9. Okay, so we have calculated the 9, and same thing we can for the distance of C will be 5. This formula is taken from this point, please keep in mind the distance of the R. Distance of the R is equal to minimum distance R comma distance Q plus cos Q and R. Please let it be know. If you have any problem, you can ask me. Yes, student, please tell me if you have any problem, because this is the most important example. Just okay, just forget right now this theoretical part. Understand the red color part only for the solving purpose. Yes, student, please tell me.
It's clear, sir.
Because each and everything should be clear for solving the question. That's why I'm saying. So distance A is equal to the minimum distance A. Okay, so minimum distance A already given to the previous part, that is we have visited at infinity. Okay, initially we have the infinity, so here we need to say infinity. Next distance as, this distance as already given into the, that is 0. Okay, and this is a table, actually this is a table where we are update all the values. So it is better idea to make a table on your paper. So A, B and C, D. In what I'm doing, I'm also solving this question along with you for a betterment. Whenever we have any problem, then we will explain. Okay, so this initial as will be distance as will be the 0, and initial A distance will be the infinity, undoubtedly without any problem, as the algorithm is saying. So we will maintain our table. Okay, so this is in this table we will update all the values time to time whenever we find. So distance from distance A, how to determine, and why we are picking the A and C? Why? Because S is directly connected to A and C. So distance A, so what is the formula? Minimum distance A comma distance S, okay, plus cost S comma A, and this distance S, how to determine Q and R? Okay, Q and R, like Q and R, like I can take the Q and R. So what is the formula? Distance R. If we need to calculate the distance of this R, so how to determine distance R is equal to minimum is a function for finding the minimum value, and how to determine distance R? Distance R comma distance Q plus cost between Q and R. The same formula we have over here. Distance R plus distance Q plus cost QR. Please keep in mind, I'm saying again because it's the most important part. Whenever you're doing any mistakes, definitely you will be suffer. So it is better idea to solve this problem along with me. Now it is clear to all. Same thing we will do for the C. Yes, friend, please tell me.
Yes, sir.
So what the distance is, what the distance we got from A and C? Previously it was infinity, so we will update by 9 and we will update by 5. Can I?
Yes, sir.
So my table will be updated.
Yes, sir.
My table will be updated. So I am doing on the my page as well, and you can also update this value. Okay. So update distance we have over here. Now see, here we have the 9 and here we have the 5, and rest of the distance from B and D will be the infinity because we have not covered or we have not visited. Okay, this is the point you need to keep in mind. Okay, then shall I move ahead?
Yes, sir.
Okay, so till now if you don't have any problem, then I can move ahead without any problem. Now come to the point. We are performing all the activity without any problem. We need to cover D and B. Now we have visited A and C, and we have visited and B. It's time to visit the B. Okay, and it's time to visit the another part. But if you are looking for the, or if you are looking the age between A to C, okay. Now if you are looking the age between A to C, or if you need to calculate the distance between the vertices A to C, now we have what we have calculated the vertices from S to A. Okay, we have computed. So I'm coming to the my point for the algorithm purpose. We have computed S to A. Can we have done? That was a 9. Did we? Tell me yes or no. हमने जी एज कंप्यूट कर ली ना, ये तो बताइए.
Yes, sir.
And as to C we have also completed.
Yes, sir.
Yes, sir.
यहाँ तक कोई डाउट किसी को? Any problem over here?
No.
Okay, so now allow from A to C we have another vertex, that is A to C we have the, or A to C is connected by another edge, that is this one. And what the value of this one? You need to see, we have the 2. Okay. Okay, so it's time to calculate the this path as well. So A to C we can say. Okay, it is
Yes.
a, yeah, so that's why we have the distance of A minimum, distance of A comma distance of C. Okay, if you are coming from A to C or C to A, it's up to you. A to D to A, you are looking for this part as a Q or this part as a part R. Okay, so A to C can be understood by the distance of A comma distance of C plus cos C comma A. So what was the previous value? That is 9. We have over written here, that is 9. And cost from A to C, what was the cost? That is 2. That is a 2. That was a 2 only. Okay, that was a 2 only. And what is the distance C value? And previously we have already calculated, that is a 5. So we need to add over here 5 plus 2, that will be 7. So the distance of A value will be updated by the 7. Can I say?
Yes, sir.
Okay.
Yes,
Now,
sir.
okay. So distance of A will be updated by 7 here because it is minimum. Now I'm just coming on that point. Before that point, let me calculate once again distance of C. Okay. Suppose I'm just coming from the C to A. Or calculate this one. So how to determine minimum? distance A, what not distance A, distance C. So what was the value of distance C? That was 5, comma, and distance of A, that would be the 9, plus distance of that would be the 2, so it will be the 11. So 5 comma 11, I which value I should pick? 5. So already we have 5. So from 11 and 5, which value is smaller? Definitely 5. So that's why we have not recomputed the distances, distance C between these two vertices. Okay, so A is already A is required to compute because we got the new value, that is updated value, smallest value 7. So we will update this value. So in the my table I will update 9 by 7 for the distance A, and I need to connect D and B and D. So I got the 14 and 9. So I again replace the 14, that is the by infinity, and this will be the 9 by this infinity. So I will update my table again. Can I do?
Yes, sir. Yes, sir. Sure.
ओके, व्हाट हैपन, ये बताइए कि ये सी मैंने दोबारा डिस्टेंस सी वो क्यों नहीं निकाला यहाँ पे? जब मैं ए और सी की बात कर रहा हूँ, इस ए और सी बटा इसको ले रहा हूँ, इनके बीच निकाल रहा हूँ कि डिस्टेंस मुझे दोबारा से रिकम्प्यूट करनी है। तो ए के लिए तो कंप्यूट कर ली, फिर सी के लिए कंप्यूट क्यों नहीं करी मैंने? क्यों? अगर मैं कंप्यूट करता हूँ तो मेरी क्या आएगी कि 11 और 5 आएगी, तो 5 ऑलरेडी मेरी स्मॉलेस्ट है, तो मैंने इसको कंप्यूट रिकम्प्यूट करने की जरूरत नहीं पड़ी। मैंने इसको क्यों कंप्यूट करा? क्योंकि इसको कंप्यूट करने से मुझे स्मॉलर मिल रही है। सो अब एग्जाम में क्या करेंगे? अगेन रिकम्प्यूट करेंगे। ओके, नाउ वी नीड टू गो फॉर द बी and now we need to go for the D. Okay, so that's why we have computed the B and C. So from the C we have computed, from the C we have computed, so what we have the B, C and CB. From the D, from the C, from this point C we have computed the this point. If A is connected to B and if is connected D, then from the A we will also compute. Okay, from now C, so C is B is connected by C and D, so from the C to B you will compute, and from the C to D you will compute. So we have computed. Okay, now if A is not directly connected to A is not connected, A is directly connected to B, so we will compute only A comma B. We will not compute A comma D because it is not connected directly. So this is the point. So that's why we have done over here. And after completing the, now see, at the first part we have this, did this. The second part, when taking the vertices in the our storage area, that is C. So A will be updated by 7. We have done. It is updated by our previous slide, and it is as it is will be, and it is updated by 9.
क्या बोल रहा हूँ?
Hello, who is?
Sir, please continue, sir. Hello.
Hello, yes, who is?
Hello, sir. Please continue, sir, please.
Okay. So since at this first level education we got the 9, 5 as you can see over here, and while taking the C, then we have updated A distance, and we got the B distance and C distance and 9 D4. And while picking the path from A, so definitely we have this path A, and now previously it was the 14. Okay, so for updating this path, what I need to do? I need to calculate the distance B from A, as I spoke over here. Now A to B. Okay, so same thing we will get over here. So B will be updated by the 8 by we are picking the A. Okay, so this will be as it is, no problem, because it is already visited. So if it is visited already, now C already visited, A already visited, then what we need to do? We will not again recompute. We will compute only the B and D. So now D. Same thing if V is busied perfectly, there is no problem over here after computing the minimum value or minimum distances. Now we will see for the D. Now at the last, after finding that C, B and D, we got the minimum distances values, then there is no more distant vertices are remaining, so we will stop our this process. Now we will get the this path. So what the path we have, that is S, then we will go for the C, and then we will go for the A, because if we are moving from S to A via C, so we will got the, what the value we will got, the, that is 5 only. Okay, so you will see this path 5 and 2 7, and rather than the 9. So this is the path we have over here. So here we have the 5 and we have the 2, rather than the connecting directly. So this is the path A to B. What the value we have over here? A to B we have the 1. Okay, and A to C to D we have, this is a 4. Okay, so this is the point we can say. So this 9 is determining, that is the, we are getting the 5 plus 4, because 5 distance covered by the C and D4, and here we are getting the 5 plus 2 plus 1. So here we are getting the 5 plus 2 plus 1 for the B distance. So this would be our shortest path for covering the all the distances. Now keep in mind, while solving this problem, your answer will be in form of the spine tree, and it will have the or it is required to visit the all the node or vertices. But note the important point: there can be multiple shortest path in the spine tree. Okay, for the same graph depending on the source vertices. Maybe I am picking the source vertex is D. Then what happened at the time? So the spine tree of my answer will be the different. So this is the point you need to keep in mind while solving the problem. But it is better idea to pick the leftmost vertex would be your source. It is better idea, because into the many example we have found this kind of situation. Now is it clear to all, or any doubt over here? Because I have the another exercise, but I will not giving this exercise to today itself. So that's why I'm saying. Yes, student, please tell me. So what was the